Hello, welcome to the wild world of sports of Welly. Alright, hello and welcome. Well, it's a new module, so we're here to start out fresh. Be sure to subscribe to the YouTube channel so you can see all the lectures, or if you need to go back to review, you can, okay? As always, if I go over something too quickly or you just don't get it, please ask questions, okay? Don't wait till the very end when you're really confused, really busy, and you might not pass, okay? So today we're talking about GMAW, gas metal arc welding, aka MIG, metal inert gas, for chapter 19. So we're going to talk about the basics first, okay? Oh, come back. All right, so we're going to talk about electricity, okay? And power sources. So there's two different types of power sources: CC, constant current, and CV, constant voltage. CC, or constant current, the current or the amperage stays the same and the voltage varies to keep the same current or amperage, okay? And CV, constant voltage, keeps the voltage the same and varies the current or the amperage to keep the voltage the same. So when we look at this volt amp curve, this thing here, okay, it just kind of drops off when we see constant current. It goes, whoop, right? But if we look at CV, it allows us to be a little bit more forgiving when we weld in terms of volts and amps. Okay, so any welding process that uses a wire feeder must use CV to get enough power for it to run. So GMAW and FCAW use a CV power source. Now CC is used for GTAW and SMAW. Okay. So next, we're going to talk about electrode extension and stick out. Okay. Electrode extension is how far the wire comes out from the from the welding tip in here to our material or to our puddle. Okay. And stick out, visible stick out, is from the end of our cup or our nozzle to there. Okay. So why does this matter? Okay, well, it matters because we're using a CV machine. So if the electrode extension is too short, right here, okay, or too long, right here, we can change the voltage, which in the end changes our heat input, and it makes it too hot or too cold. So this is like autocorrect for welders, okay? Just like autocorrect on our phones, sometimes it types words that don't make sense. So if the electrode extension is too long, the machine senses that it's too cold. We need more power. We need to make it hotter, okay? In the end of this, we might burn a hole into our material. Now, let's think about it. If the electrode extension is too short, we can have the reverse. The machine senses that the electrode is too hot and turns down the voltage. In the end, our weld comes out too cold. Okay, so we need to make our electrode extension a happy medium and keep it constant. This is the hardest part about GMAW. Okay, so we're going to need some equipment. All right, we need a welding machine that is capable of DC power and CV power. Otherwise, it just won't work. Okay, we also need a couple of other things. A wire feeder. Now, this can be like the wire feeder in the picture, or we can have a wire feeder called a suitcase. It allows the welders to attach the suitcase to their machine and make it more portable, like in the field, okay? So we also need a ground, aka it says workpiece connection, okay? A welding gun. If we're doing MIG, then we want to make sure that we have all the correct MIG accessories for it. A shielding gas. This is required to make the welds. The regulator, okay? The shielding gas must be attached to the welding machine, but the machine doesn't regulate the PSI or the flow of gas, okay? The machine only says, is it on or off? There can also be extra equipment, okay? This makes it automated or robotic, and it's becoming more and more commonplace. But we really need to understand how it works before we can be an operator, okay? So when we attach the wire feeder, we're taking the electrode wire and gas and having it come up the lead of the gun itself. So if we look, what happens is in the back here, our gas is attached, and here's where our gun is attached. The gas and the wire is actually fed through here and comes out all at once. Okay. So you need to be able to recognize the components of your welding gun, and we want to make sure that they're clean and in proper order. So here it is. Here are the different components. Okay, so we're going to talk about the handle and the trigger. Okay, these are the nearest the welding lead. Okay, then comes the conductor tube. It's also called the gooseneck. These can come in all kinds of lengths and angles of bends, depending on what you're using it and how you're comfortable with it. Okay, the next is an insulator. This is actually a little plastic insulator. Okay, and make sure that you're not grounding out, and it protects parts of the gun from melting. Okay, so here we have is the gas diffuser. This is where the gas actually comes out of our gun. So you need to make sure that there's no spatter on this part, otherwise you could have lack of shielding gas. This is bad, guys. All right, the next, the contact tip. Doo-doo-doo. All right, the contact tip is where the magic happens. The contact tip should be the same size as your electrode wire. If it's too big, the electrode can shatter around and ground. If it's too small, it'll just jam up in there. So you need to make sure that this tip is clean, otherwise it might block the wire from coming out, okay? All right, the gas nozzle, also called the cup, it directs the gas where it needs to go. If the cup is dirty, the gas may be blocked and you end up with lack of shielding. What is this? Bad, okay? So also we need to remember too much gas can be too much and it can create turbulence and it doesn't protect you well. Not enough gas and won't shield properly, okay? So just because it's more doesn't mean it's right, okay? We need to make sure that we have the correct amount so it works well. All right, so there's also a different type of MIG guns available. Some are straight, some are curved, okay? When we work with extremely high amperages, they also have water-cooled guns. And then they have some with a special tip on it that even has its own fume extraction. These are pretty expensive, so this is usually done in like production areas and things like that. All right, onwards. All right, so I was saying the wire feeder advances the wire through the cable liner to the gun and then to make an arc, okay? Wire feeders can use all sorts of different types of wires, like flux cored wires too. So in order for the variety of wires and wire sizes, they need drive rollers, okay? These advance the wire in the machine. So drive rolls, they have to be the same size as your wire you're using, otherwise it'll just slip around, okay? There are also special drive rollers if we're using flux. Well, since flux wire is tubular, which means the wire is on the outside, and the flux is in the middle, it can be crushed, okay? So we want to make sure that we use a knurled roller so we don't have to put so much pressure on it. And those little knurls right here, they kind of grab the wire. All right. U-grooves are usually used for softer metals like aluminum, and there are all kinds of ones like even Teflon coated ones, and those are usually used for slippery materials. Okay, there's also different types of guns. Okay, they have a special gun. It's called a push-pull gun, and it has a little spool inside the gun itself, and it's made for like materials like aluminum that tend to slip with traditional drive rollers. So it just pushes it out and pushes and pushes. And that means we don't have very far to go for it to have issues, okay? Okay, well, let us see here. All right, so I want to tell you about tension on the drive rolls, okay? So in order for these to work, we have two drive rolls, one that sits on top of another, and the wire goes down the center, okay? And we need to put some sort of tension on it so that it'll actually advance the wire. But if we put too much tension on the drive rolls, you end up crushing the wire, whether it's solid or not, and we can create what's called a bird nest. I call it a crash, okay? So if it's too tight, it kind of peels off the little particles, okay? And then it creates issues. So what you can have is it catching in the liner. Okay, so the liner looks like a really, really long, tight spring, and the wire is fed in the center of it. So if it gets kinked or if the wire is bent, it can make an issue. We can back up, we can, get burned back in the tip, melt the tip closed, or we can just have a big old bird nest, okay? So we want to use little tension as necessary. So you need to make sure that you check tension every time you use your machine. To set your tension, we want to loosen the tension until the wire starts to slip and then tighten it one turn. No more tension is necessary than that, as long as the wire moves forward. Okay? And you can kind of tell if it's too much because you'll actually see when the wire comes out before you're welding, it'll actually have dents in the wire. Okay? And then we know it's too tight. All right, so in order to protect our weld, oh, here's our drive rollers. See, this is what I wanted to show you. See how they're on top of each other? Okay, that's exactly it. All right, so in order to protect our weld, we need to make a bubble of inert gases that shield the outside atmosphere. Okay. When we talk about inert gases, they don't react with the metal, so it makes it good to shield the arc. Okay. CO2, argon, and helium are the majority of gases that are used. They can also be a mixture of them as well. So we have this chart here. You also have this chart in your book. So if you need to go back, you can always look in your book. So different gases also affect contour and penetration. What I mean by contour, the shape of our weld. Okay. So the most common shielding gas is CO2. They say though that 100% CO2 penetrates too much for sheet metal and that there's a lot of spatter. The preferred gas for bodywork or sheet metal is 75% argon, 25% CO2. This allows for good bead contour and decent penetration. But one of the disadvantages is that it's not meant for outdoor use. Any breeze, wind, draft, fan, and even really fast travel speeds can blow away your shielding gas. This is called gas drift. You can use a windbreak to help this, okay? So we can have a little something to block it, okay? But more times than not, it's easier just to weld indoors with GMAW, and most of GMAW is done in the shop, okay? All right, now, we're going to talk about filler metal next. All right, take care.